Today my talk, I'm Mckenna. I'm the director of field engineering over here, so I'm responsible for being the voice of the customer. My talk today is effectively just getting your data AI ready. So you have a lot of raw data and you want to get value out of it. That's what my talk is about today. So just to kind of set the stage, we only have about 20 minutes or so for this presentation. I want to show you a nice demo of how we do this. But effectively, where we start is a situation like this, where we have many different tables. The tables themselves are very, disjointed. There's, aggregations that need to be done. There's potentially missing data. There's outliers. It's different sizes, different frequencies, right? And you need to take that data, right, that environment that may be in different data lakes, data warehouses, tables for sure, and create a situation where it looks like this, a flat table, right? So that is the input for any typical machine learning model, right? Regression, classification, and so forth. So the question is how do we get from here to here? That is what my talk is going to be about today, okay? Now, before I get into the tool that's going to help us with that journey, I just want to talk about kind of two key benefits the tool is going to be able to provide for me. This tool is called dotData Feature Factory. Now, the first is that when you want to take your data that's disjointed like that and be able to gain insights, effectively perform exploratory data analysis from a machine learning lens, you have to do a lot of testing, a lot of exploration of that data, right? I mean, everyone is doing things like creating plots, creating histograms, looking at distributions, things like that, right? But you also want to generate potentially features, right, that are going to be powering the machine learning models. And so how do you do that today, right? You can't search for everything under the sun. If you have a small data set, a very small problem, a few number of columns, you may not necessarily need to do this. But if you have, a relatively moderate-sized data set or a big data set, it's going to take a lot of time to do that. So you talk to a subject matter expert, right? Or you build some domain expertise yourself. And you iterate with that subject matter expert in order to retract the size of the potential space that you're going to be exploring. What I'm posing here is a different strategy, which instead is a statistical strategy, where you instead are just letting the data speak for itself. So instead, you're posing many different questions, not just 10, 100, or 1,000, but I'm talking about potentially up to millions of these different questions at the data. And then you statistically let the data surface those features that have the most correlation, most impact with respect to the thing you're trying to predict. So one example of how we can boost productivity is exactly what you're seeing right here. So in this example here, what I'm saying is, okay, let's pose one particular question to the data, right? Which is, first off, we have to identify what that question should be, which is typically either just simple, domain expertise or just kind of looking at the data and just kind of trying different things. So in this question, that is, do engineers who withdraw lots of money in the past month churn, right? That's something that we want to test the data set against. And of course, when you test things, it takes time. This is an example here of where if we were to do this manually and it's coming from different databases, we'd have to potentially write some SQL code in order for that to happen, right? That could be more of a heavy-duty type of testing scenario. There might be ones where it's simple, just copy and paste from one Excel spreadsheet to another. But effectively, there is some amount of time required in order to test. And that's just for one simple hypothesis. In this case, the hypothesis is, do engineers who withdraw lots of money churn, right? And if you want to do that at scale, you want to do that for 10, 100, 1,000, 10,000, so forth, right? It just simply becomes impossible for someone to do that without some sort of automation capability. So what I'm going to pose you today is a tool that allows us to automate that testing, and then we can take our intuition, our knowledge, and we don't have to be a full domain expert, but we can take that and marry that with a statistical tool like this to really gather insights and jumpstart our machine learning process. The second thing that is typically a challenge when you are doing feature engineering, feature exploration, is that it's a process that's very ad hoc, it's very bespoke, right? So you're trying many different things. Effectively, you want to fail quickly so that you can succeed fast, right? So you're trying different things. You're not necessarily writing code that's going to be, battle tested. It's going to be like, it's going to be able to have like abstraction and encapsulation and things of that nature, right? Best OOP practices. Instead, you're simply just, banging out code that may not necessarily have great naming conventions. You're throwing it into different Jupyter notebooks. You have different types of data sets that you're working with. And when you do that for use case after use case after use case, you effectively, or what you're doing is you're creating technical debt, or you're making a decision to throw away these assets, these features, and these feature pipelines that you're constructing that could potentially be valuable in a new use case. And so what I'd like to pose is, how can we make reusability and sharing of these assets more forefront as compared to this previous approach? So, last slide, I promise, and then I'm going to jump into the tool. I just simply want to talk about the shift and how we're going to do this with a tool like dotData. So above here, what you're seeing is effectively, sorry, let me just move over here. What you're seeing is that we're taking some raw data, right? This could be many different tables from many different locations, and you're going to iterate with a subject matter expert, right? And effectively, you're going to continue to iterate, come up with new features. Maybe the window of period of time that you're looking at isn't quite ideal, and to say like, okay, 1 month isn't perfect. Let's try 2 weeks instead, right? Or maybe, hey, I've got a new data set. I want to enrich my existing data set with some new data and see if that has value, right? So you're going to continue trying these things over and over again, creating many different experiments. Effectively, you get to a point where you have a summary table, effectively a bunch of different features, right? And that can either be pushed into kind of a traditional feature store, right? Or that may be your end result, right? And you have all the features that you need and then you're good to go. Typically, what we've seen by talking with many different customers is instead, in order to, or trying to provide some reusability, they take the features themselves and store them directly within that feature store or that database of features. And then they'll take some sort of tool, like maybe like backwards propagation or some other tool to do feature selection. That approach of doing feature selection typically tends to be very slow, right? Because it's a machine learning based approach that's dependent upon the model that you're using. It's not model agnostic. And then you're selecting from that pool of features, right, to come down to a subset. So as the number of features in these summary tables that you're seeing here expands, that means also that your process of getting out the features that we care about here takes longer, right? Takes more compute. So how do we go about creating a situation where that's not a scalable, that's not scalable, right? We want something that is scalable. So what I'm going to show you here in dotData is an alternative approach that can be married with the more historical-based approaches or classical-based approaches. So instead, what I'm saying here is that you have raw data, and instead of just talking with the subject matter experts and iterating in the beginning, save that for later, right? Instead, let's take that raw data, take it all and throw it like in the kitchen sink, just throw it all at the problem and see what surfaces. And there are 3 key things that we'll need to do in order to surface those aha moments. The first is that we need to define what it is that we're trying to predict. So that's the target variable, the prediction. We also need to define, if we have many different tables, how they're connected together. So what are the keys that connect these different tables together? So that's step number 1. After that, it will generate features. So then you want to explore potentially the features, or maybe modify the feature space, all the different types of combinations of these different features you're putting together, right, and constructing. So that's the second step, right? Explore feature spaces, refine it. Maybe, for example, there's certain columns after talking to a subject matter expert you do not want to include. Maybe there's some, HIPAA data that you don't want to include, or, specific demographic data, things of that nature. So that's the second step. And then the third step, the final step, is really just selecting those features from that leaderboard that you like, and then building the feature pipelines, right? And then using those feature pipelines in production. After that, your data is AI ready effectively. So what I'm going to show you here is that process within a tool called dotData. Okay. So this is dotData Feature Factory. It's a tool that effectively is a library that enriches your Jupyter Notebook by providing two key deliverables. One is a API that allows you to programmatically build these features very quickly. The second are these lightweight apps or user interfaces, like this one you're seeing here, that allow us to do feature exploration. It's one of the tools that I've noticed as doing data science that we tend to lack, is having feature-centric based exploratory data analysis tools, such as this one here. So that's one of the things that dotData provides in kind of that lack of the ecosystem. So what is this that you're looking at? This effectively could be an end result where you have, in this case, many different rows. Each one of these rows here is a feature that dotData built and then surfaced as being statistically significant with respect to the thing we're trying to predict. I have not told you what the data looks like originally or what the thing is that I'm trying to predict on purpose, because dotData, again, is a statistical tool, and we are agnostic with respect to the problem, the industry, or the use case. You simply take the data, throw it at dotData, and then we'll surface those signals. In this case, just so you guys are aware, this happens to be determining whether or not someone is defaulting or not. And there's 3 different tables. Those are the key things you guys need to know about this data set. Now, when we are going through and exploring the potential features that have impact with respect to someone defaulting, these are the things that are surfaced in that data set. So what you're going to see are features that have many different types of components. Let me just zoom out here a little bit. So as an example, sorry, I'm just looking for my cursor. Okay, there we go, I found it. Okay, so what we're building here are many different types of combinations, effectively like Lego building blocks, putting these different components together to build these features. And so what features consist of are typically a couple of key pieces. They'll have a piece that's related to, as an example here, whether someone is, any record satisfied. There's some sort of aggregation piece. That's what this piece here is saying. So it's typically an aggregation piece. There may be a thresholding piece between different thresholds. There'll be pieces, as an example here, where there might be filtering based on different conditions. There'll be things like look-back periods of different windows in time, right? And so what dotData is doing is effectively looking at all of that, including different interactions between different columns. dotData will look at up to 4 different columns at a time. There's no other tool that can do that type of exhaustive looking through your data set. Simply because the number of interactions that you look at is exponential, right, in terms of the amount of compute. And the reason that we're able to do this, there's 2 key capabilities the tool allows you to do. One, it's built on Spark on the back end. For those that don't know what that is, that's great. You don't need to know what it is. For those that do, you'll probably appreciate the fact that this can scale. We build this on top of clusters. You can throw more compute at it. That's one of the reasons you can scale with big data sets. The second thing is when you are evaluating many of these different features, right? I'm not talking about thousands. I'm talking about millions of these different features. Typical approaches mean that you have to store that in memory, right? And obviously, if you have a lot of different rows and you have many different features, that just blows up. So you need a process, a way to do that in an out-of-memory approach that's also fast and accurate. And so that's one of the proprietary capabilities underneath the hood that allow you to really explore and scale and look at many different situations within that data. So effectively, you get to a point where you have a flat table that looks like this. And so the question is how did I get to this point, right? How did I get to a point where I can now explore and try different things? Like as an example here, this is being ranked based on the feature lift, right? So maybe I want to look at those that have the most lift, right? Look at just those first, and then expand my search to see if there's other types of features that are maybe of interest that maybe I want to socialize with a subject matter expert, right? Or again, maybe I want to make my model itself, I don't care as much about accuracy. I care more about being able to explain it, right? So I don't want collinearity between the different features. I want them to be as orthogonal as possible, right? So then you just simply change these different parameters here, and it will show you kind of the key things to look at first, right? And then you can further explore this in more detail. So the last thing I just simply want to show you here is how did I get to that point of building those features? So really, there are just, again, those 3 key steps I showed you in that slide. So the first here is setting the tables. So again, you just define as many tables as you want. This is in a Python dictionary, so I can have 5, 10, 15, whatever amount of tables that I need. I connect them together or define them here. The second step is I define the connections between those different tables. So an example, I have a transactions table and a clients table, and I'm connecting it based on the client ID. And then the third step here is just simply defining what it is that I'm trying to predict. What is the type of problem, in this case a classification problem here, and I'm trying to predict default, which happens to be in the loans table. After that, dotData will go through and construct the features for you and the pipelines themselves, which just do a simple command called select features here. So you get out the feature table, that flat table down here, and also the pipeline too, where you can select certain features of interest, right? Which is the first thing that I showed you in this demo here, which is effectively just this down here. And you can decide, okay, these features do make sense. I want to include that in my feature pipeline, or maybe I don't, right? From there, you can then generate SQL code or take that pipeline, save it to disk, load it up in another Jupyter notebook, and then deploy that. So that's effectively dotData in about 10 minutes or so. Do we have time for questions, or are we past time? We have time for questions? Okay. Questions? Yes, sir. How do we handle leaky features? So that's a great question. So there's actually technology in here that allows me to first detect whether or not there are leaky features inside here. So there's underlying technology that allows me to look at making sure that there's a certain period of time. For example, we're doing time series-based data, that we're not using time series data that is in the future, right? So every time that we're looking at like a window of time, we're making sure that we're only using that historical data. Yes, sir. That's another good question. So one simple way that we do that is that if data is above a certain threshold of missing in a certain column, like say, for example, 90%, we'll just simply drop that. But you can customize what that threshold is in the tool. Question?
How are the features being generated?
How are the features being generated? So that's a really good question. It's also a very broad question. So to answer that kind of in a sweeping answer, the features are being generated by effectively trying different types of combinations in the tool. So there's this concept called the feature space, which I did not show you just simply for time purposes, but the feature space, which you can see here, consists of joins, filters, and aggregations. And effectively what we're doing is you can programmatically specify custom joins and filters and aggregations, but there's also a default feature space, which you're seeing right here, built directly into the tool. And it's dependent upon the context of your data. So it will go through and build different types of aggregations. For example, if I'm looking at distributions, it's going to look at the distribution of my account balance, right? Or transaction amounts or things like that. That's dependent upon the data, but also the aggregations themselves are part of that default feature space, which you can also customize too. And so what dotData will do is it'll take all these different combinations and try them all out. Of course, before it does that in a brute force way, we're going to be smart about it. We're going to profile the data, and if there's certain things that just simply don't make sense to do, right, we're just going to drop those potential combinations. Yes, sir.
So a lot of these times you might have features that might have correlation but may not make sense from business perspective. Is that the user's responsibility to take them out?
Sorry, I can't hear you.
So I'm saying a lot of times you might have features like let's say ID, which has no business relevance, but it's due to correlation, it might come on the top. So feature engineering or business like how does it feature?
So the question was, there's certain columns, for example, like an ID, right, which just based on the way the data is set up, potentially could come up as being one of the top features, and how do you deal with that? Is that correct? Yeah. So there are two things that you can do. First off is that if you know there are certain columns that you want to disable, you can adjust that directly within the feature space. So as an example here, if this happened to be the ID, the feature ID, and we don't want to do those aggregations on feature ID, we simply deselect it. So that's one way. If we know beforehand, after the fact, if you don't do that, it'll just simply try out those different types of combinations, which of course will take a little bit more compute time. But at the end of the day, you'll see them inside your feature leaderboard. And so you can quickly remove those, right? So if I go down here, right, I can quickly search for those that are built on specific type of ID. So example here, district ID, as an example of something that's built on an ID. I can immediately see those that are I do not want to include, and I can easily remove them from my list right here by just simply saying don't include them. Yes, sir.
I may have misunderstood, but maybe you said that feature selection is not broadly defined. Entirely depends on the model. It seems that later on you said that the system feature selection is broadly defined. When you choose to exist that selection, nothing goes.
Great question. So the question is dotData feature agnostic? How are we doing the feature selection there? And so I just want to kind of demystify that a little bit. So when we are doing the feature selection using a tool like dotData, you do need to know what the target is. So you do need to know the thing you're trying to predict. It builds features based on what that target looks like. And so if you do different things, like for example, if you're looking at churn, right, and you're looking at churn on a monthly basis versus a daily basis, that's a different type of target variable. There would be different types of features that would be uncovered based on that different target variable. Now, the way that's being done behind the scenes, and I can't give you too many details around that, but basically it's a regularization-based approach in order to identify those features. What I've seen folks, and you can do this also with dotData too, is that you can run machine learning on top of that, where then it becomes model agnostic, and you're trying to tune the set of features that are going to then be passed into the model. But what we are doing here is we're selecting features on an individual basis, looking at each one of those and how they correlate with respect to the target variable. And that piece itself is agnostic to whether you're using a XGBoost model or TensorFlow model or whatever it is. The second step, which you can certainly do as a approach after this too, is that you got a list, a feature leaderboard of 50 or 100 features, which is, again, an input that you specify. Return back 50 features or return back 100 features. And then from there, you can then further refine that in a specific machine learning model by passing in a subset of those features and then iterating on that. Does that answer your question? Yeah. Okay. Yes, sir.
How do you handle the categorical values? How do you handle categorical values? Do you do orthogonal encoding or parallel encoding or whatever?
Yeah, the tool out of the box does both. So we do, how do we handle categorical variables? So we do one-hot encoding, we do target encoding as well. We're also working on a couple other encoding techniques too in the categorical space. I'm not sure if they're in the newest tool or not, but those two are definitely supported right out of the box. Yes, sir.
Could you explain about the quantity features required?
So the question is can I explain a little bit about the computing resource required? And yes. So the computing resource depends on it depends on your data effectively. That's the short answer. But it depends on things like the number of joins that you need to do between different data sets. So if you have many different data sets, and as an example, you have a time series based join that's doing aggregation on a certain window of time, it's going to require more compute resources. Also, of course, the amount of columns in your data set, the amount of rows in your data set, obviously are going to take more compute as well. If you're interested in learning a little bit about how much compute would be required from a tool like dotData, I can give you kind of a very general sweeping answer, but also we have a tool that is a calculator that allows you to see exactly how much compute would be required. But in general, if you want to take a data set that is, let's say, on the order of gigs in size, right, and you want to connect that with, let's say, like 5 different tables, you're looking at on the order of a couple of hours of time in order to do that compute. We're talking about like maybe like 5 hours or so, to give you an idea of how much compute would be required. Yes, sir?
What are your limitations in the target? Can you target time-based, not just like a typical variable? What are you doing with query, like data mining or rare occurrence linkage, right? Or these target?
Yeah, so the question is what are the limitations on the target variable? So there are a couple of limitations that you should be aware of course. One is, how many different rows that I need to compute in the target variable. I believe our limitation right now, out of the box, and it's potentially something we could adjust to, is 10 million rows. So that's the number of rows that you compute for a target variable per experiment. So that's one. The other one is talking about more about bias in your data. So if you've got 1% or 5% of a particular class, can dotData deal with that? And the answer is it depends. So if you have a very small amount of a particular label in your data set, dotData will warn you. In this command I showed you above, we're talking about target leakage. There's also looking at things like the distribution or the different classes in the data set. And if you have enough of those, it will warn you that it may not necessarily give you accurate results if you don't have above a certain threshold, which I believe is like 5%. But it's also looking at the data too and the profiling of the data. So the answer is, I guess it depends. Yes, sir?
Answer that example
By oversampling? You could do that, but that's not in the tool. So that'd be a step outside of dotData. Yeah. Okay. All right, guys. Well, thank you so much. I appreciate the time and all the questions. Have a great day, guys. Thank you.